how this technology that they built for analyzing the pattern of cars on the racing track. And I present to you Magnus and Avik. What do you think?
Thank you, Gautam, for the introduction. And can you hear me? Can you see me? Great. Thanks for the introduction, and thanks for giving us this great opportunity to present our project. So what this project is about, so its main purpose is to show it at exhibitions and fairs. So that's what PwC set it up for. They somehow want to show data analysis capabilities, and they thought, okay, what draws the attention of visitors of fairs? Probably a slot car racing track is something really nice to show. So, and that is the racing track that you're seeing right here in front of me. So what they did is build this racing track and equip it with a couple sensors. So the first sensor we have is a camera sensor that you're right now seeing me directly in the picture. And the other sensors are light barriers that are built into the track. So we have one here, a couple here on the straights, and some other here. And what they did before was analyzing the timestamps of the light barriers together with taking individual pictures with the camera, sending these pictures to the cloud, analyze them, identify where the cars are, send the results of the analysis back, and by that identify which car drives on which track. So our project team thought, why don't we take this somehow to the next level to do a video stream analysis. So we don't only take pictures and do image classification and localization in that, why don't we do an object detection? So this is the first somehow stream of our project. To the second stream I will get later. Before we're getting into the technical details, I would like to demonstrate the car driving, because it's also lots of fun, obviously. So this is the Ferrari driving here to give you an impression of how it looks like in the end. And for the details of our first work stream, so the object detection, I would hand over to Abik, who's also sitting right next to me.
Thanks, Magnus. Thanks a lot. As Magnus showed you around a car driving and he's streaming it live from the camera, this is one module that we are as a team working on, that's object detection. And currently we are in the phase of collecting data. As you saw the feed from camera, we want the data to be as diversified as possible, like from different angles, different lightings, different background, the shades down, more colors in the background, different things. So why are we doing object detection? The issue here is that we have two cars on the track, and we want, like while the video is streaming, we want to map that the car is moving in certain direction and it keeps on tracking it till it's totally completing its whole lap or not. For the object detection, we are currently planning to use a YOLO model. You guys may be asking, what is a YOLO model? It is a image detection and classification model. The full form of YOLO is you only look once. Now, why are we using the YOLO model? The reason for using the YOLO model that it is now the state-of-the-art model for object detection. But we have another reason to it. It is trained on a COCO dataset. The COCO dataset is a dataset which contains car as one of its contains car as one of its label. It has data which contains car, and the model YOLO is trained on it. So we in our track is having a car, and we want to do transfer learning. Thanks, Danko, for explaining the transfer learning. This makes it easier for me to show around what we are trying to do. Now, with the help of this pre-trained model, that's YOLO, we are trying to customize our data according to our need and freeze a few layers in the initial architecture of the YOLO and just change the values or the weights of the last layers. So that's our one model, and I'll share my screen and show you the current architecture, like the current version architecture of YOLO. Guys, can you see my screen? So yes, as you can see, the YOLO model is not just a conventional neural network. It is a layer of conventional neural networks which are pooled one after another. There's a lot of attention-based architecture going on in between. There is a few steps system going on, and it is really it's a really very good architecture which is way different, and it's still improving. Like they are currently in version 4 or version 3. Now I'm going to talk about the part where yes, so this serves our purpose of using the YOLO model, and summing it up right now, the focus for one model that I'm focusing, or we as a team is focusing on, is identifying and detecting the cars on the track, and Magnus will further discuss about other potential modules. Handing it back to Magnus.
Thank you, Abik, for a very detailed explanation of our object detection. So this was our first work stream that we had, the object detection of the cars. The second thing that we thought of, so as of now, there's at the exhibition, there's two people driving against each other, and they're somehow competing. But we thought, wouldn't it be cool to somehow let one car drive autonomously, so that we somehow compete with the AI, drive against the AI. And as already mentioned, we kicked this project off 2 weeks ago, so we're still in the initial starting phase, and this is where we want to ask you, the audience, a couple of questions. How to make these cars or one car drive autonomously. So feel free to post in the chat or just say something otherwise. We will also publish a Google form that has a couple of questions in it that you can populate. So to get to the questions themselves that we would like to ask you. First is, how do you think we can control the cars digitally from, let's say, Python or something, from a laptop or Raspberry Pi? Yeah, so that's the first question. Second, what do you think, what is best on how to train the AI to drive one of the cars? So, I mean, in the end, you only have the possibility to push the throttle more or less. And then, of course, also other ideas, other inspirations that we'd be happy to brainstorm together with you and get in touch. And if you have something, feel free. Otherwise, I would get into the details of what we thought. So currently, the way of steering the cars, I mean, it's through this controller. So we thought, okay, maybe we can hotwire the controller in a way that there's some signal from a laptop coming to a device that we would set up that's directly connected to the controller. Because in the end, what this controller does is only sending one number or one signal to the racetrack. There the problem is you need some electric engineering skills. We're data science students, so we're still looking for support on that. Otherwise, do you guys maybe have an idea for how to steer these cars, or maybe something completely different? Would be happy to discuss these things. And yeah, so there are a couple couple ideas outside for steering the car at the moment, but these mostly focus on different track type. So we're somehow bound to this track type for now, and yeah, as you might know, Gautam already mentioned a little about it. Especially in robotics, reinforcement learning is a growing field. So I don't know if it's the best application for us right now. Might be a little overkill for our project, but yeah, this is all something that we thought of, or something to, yeah.
Okay, so anybody has any question? Till someone ask, I wanted to give some suggestion and ask questions. Suggestion is you just need to control those controllers. Why don't you use some sort of GPIO based board and Raspberry Pi? This tool will help you solve it easily. You need a Raspberry Pi where you can put your trained YOLO model as well, so you don't need your cloud service. Every frames can be analyzed directly on the Raspberry Pi, and then a GPIO connector that will be easily connectable and operable to this controller. You can use that. You don't need to send the data to the cloud to do all the analysis. It's overkill for whole project. And the question is, even if you want to, let's say, send the data to the cloud for all this video analytics you are doing, there will be time lag, the delays. And is it necessary for your project to have this time lag?
So this I need to explain. So before they sent to the cloud, but for the object detection, we want to do everything locally. So we thought of running the object detection model on a laptop because we didn't know whether a YOLO model might extend the computational capabilities of a Raspberry Pi. I don't know, are you familiar with that? Because yeah, that's somehow what we thought of. And the Raspberry Pi doesn't provide enough computational power to do 30 frames per second object detection. And then, yeah, let's also the other part would be how, so you said connect the Raspberry Pi over GPI, GUI to GPIO connector. Okay, so through that, we're able to directly connect it, or
yeah, you can connect the controller to the GPIO pins and then control basically via Raspberry Pi.
That sounds really cool, because running locally will, for now, be definitely a requirement if you want to show the video stream. I mean, there's no way of sending the data to the cloud and then showing the video stream. The latency is just too big, as you mentioned. But it's a really good idea. Thank you for that.
You're welcome.
Definitely dive deeper into it.
So there's one question. Instead of controlling the analog controller, you can switch to Carrera Digital and write your Python library or Python lib, or use existing one for Carrera and connect directly to the Carrera CI. I think that is also a good suggestion, because there are some Medium post I read. There are some guys who were basically, the Carrera library itself is a Python library for particularly playing with car racing things. And you can generate a lot of data from that actually. You can probably find this Medium post where some guys did the project and they published the whole code along with the article, how they built it. So any other question? I have a question. Why did you choose YOLO? There are many other models. One-shot learning model is also another solution. Why did you choose YOLO? Is it because it is already trained? And because I don't see that many applications of YOLO, but rather a lot of other existing models. Why YOLO?
Okay, so I will answer this question. The thing about why specifically YOLO, we thought we went and looked into Mascar CNN. There is faster CNN, faster CNN, and like there are various different other models. These are just the top four that comes to my mind. Most of the models are trained on ImageNet data or some other data set, and we went into the specific data set. We want a data set which, like, we want a model which is trained on a data set which is specifically having car as a label. And while looking through the different models, there is a version which exists for, let's say, Mascar CNN with Coco dataset. It was getting a bit difficult for us to access the weight, or we were not able to find the right model or stuff for the pre-trained weights. That's why, like, while doing our brainstorming and while reading through articles and finding it online, we found YOLO to be very useful. And we saw that we, like, for example, YOLO not just provides us, like, if we want to implement it, we just cannot, like, we could implement different parts of it. Like, there is a tiny version of it, there is a mobile version of it, there is a darknet version of it, there is a whole like the full scale version of it, which, like, gives us very much functionality to decide whichever we want to decide. Like, for example, as you were asking, like, we were using, why should we use cloud? There would be latency. The thing about this track and the camera is, like, they are going to move this to different exhibitions, different places, and they might not have the same laptop or the same device on which the model is trained and stuff. So for them, it becomes really mobile, that they connect directly to the cloud. If they have a phone on which it is already stored, it becomes much more easier for mobility perspective also.
Okay.
So that's why, like, YOLO, and that's why, like, the cloud was in our radar.
Okay. Yeah, I mean, I see your point. I just think if you have to run it locally on a Raspberry Pi, custom-built model would be one easier solution. But if you want to have a trained model and just take the weights, then of course you need to find out a better solution in terms of resources. Yeah.
We gave a thought for the Raspberry Pi too, but what happened with is, like, we tried to load a few models, like we tried to load a very basic models on a random PC like my PC and Magnus's PC, and, like, without GPUs, my and his PC without GPUs, we tried to load it on the normal CPUs. It was not getting loaded, and we thought that this would be not be able, like, definitely this will not be able to be getting loaded on Raspberry Pi. That's why we dropped the idea. Like, that was our main focus to, like, Raspberry Pi was the main focus for mobility, but then instead of Raspberry Pi, we thought, why not cloud, which is much more better in terms of mobility.
Right. So just a quick suggestion from Daniel. Why don't you use simulations like one of the GitHub repository from AirSim? But maybe you should note that. And there is one question from Danko, or let's say two questions. Can you explain the challenge of the game? The first question. Second question is, why can't you simply press full throttle and hope for the best? Is it that sometimes you need to run slower speed than maximum?
Okay. Thank you. It's a very good question. Imagine you're at the exhibition and everybody is just we're competing. That's what happens pretty fast, and that what's happening pretty quick. So just being the fastest is not the best goal, because then somehow the flow of the whole project is disturbed every 30 seconds because the cars are flying out of the track. So the main purpose should be to somehow compete against the AI in terms of driving more constantly. For example, we would define specific sector times, and if you're either above or under these sector times, then you're getting a penalty. And I mean, then you would need to introduce some bias for the AI probably, because if the AI is just perfectly matching these sector times, then it's also boring. But yeah, this somehow, the goal shouldn't be to drive as fast as possible, but we would need to think of different targets, like driving more consistently. Yeah.
Okay. We have any question here? But sounds interesting. And I think you guys
should show us again once you have developed your first version, something like that. Yeah, I think this is a fun thing that people would like to see how AI controls small cars on the track.
Would be a pleasure. Thanks.
Thank you very much. Okay, so with that, we move to our next talk. This time we do not have the AI movies to think about. We thought it might be overkill for all of you. So we kept it out since we replaced that with the demo, but we promise that we will have it next time. And we have some cool movies lined up, and it will make you really think